Average Schmaverage, Part 3. In this video we are going to take a look at how data can get skewed and how that is represented on graphs and histograms. We are also going to take a look at an alternative to the average called the median, and pros and cons of the average versus the median. So, the three graphs that you matched up in the classes in problem 7 are called histograms. While all three classes have the same average of 7.25, their histograms have very different shapes and tell a more elaborate story about the data. So we can take a look at these three pictures and say that the first histogram is symmetric in shape. If you made an imaginary line vertically down the middle of the graph, it would be the same on the left and the right. You could also fold it from the left to the right or the right to the left. The second histogram is called skewed to the left. It has most of its grade on the right, high grades, and then trails off to the left. Imagine that we connected a large bed sheet and made a little bed sheet fort from the top of this tall piece to the bottom piece. It would be skewed or pulled to the left. Whereas the third graph is skewed to the right. The graph has the opposite effect of this one on the left, and most of its data is on the low end instead of the high end. And again, a bed sheet making a little bed sheet fort would see that this data would be skewed to the right, with most being on the left, and the average would be pulled to the right, as in this example, how the average would be pulled to the left. So if we took off these two values, the average would be right here or somewhere here slightly to the right of the middle, but as we add data points on the left, the average is skewed to the left. And the same thing here, if we only had these two bars, the average would be very close to the middle, slightly on the left here, but as we add data points to the right, the average gets skewed to the right. So the next piece of this problem is for you to create and label three histograms, skewed left, skewed right, and symmetric. And then explain why the graphs that are skewed right or skewed left might have misleading averages. Pause the video, do this little activity. I'll show you one possible example after you unpause the video, and you can take a look and see how you feel about your answers and compare them to mine. Alright, so the first histogram, skewed left, is going to have most of your data on the right-hand side. So imagine a skyscraper skyline histogram that will trail off as we get more and more to the left here, smaller and smaller, maybe some gaps, but you can definitely see that this is having a skewed left appearance, whereas the skewed right are going to have most of your tall buildings on the left-hand side, and as you go on, you'll have maybe some gaps here, and again, your pictures will vary, but you can see here that this is considered skewed right, and symmetric obviously would have buildings matching appropriate heights to the left and to the right of each other. Maybe not exactly the same height, but this gives a nice symmetrical curve to it. And then in terms of why the graphs that are skewed right or skewed left might have misleading averages is because even though there is a majority at one part of the graph, the small amounts at the extremes are going to pull the average away from the heaviest concentration of buildings, or in this case, your number sets. So on the second of three pages here, we're going to look at maybe an alternative to the average. In case of these skewed graphs, we maybe want to use a different kind of measurement. So maybe the median. And the median is often a better measure for the middle of skewed data since it seeks out the middle data point and is not affected by outliers. So for number 10, we're going to find the median of each of these data sets. Now the median, just like the median of a highway, is finding the middle number. And it's pretty straightforward to find that the middle of these 5 numbers is 4. So this would be my median. The median is 4. And in the middle of these 5 data points, the median would also be 4. Now the reason why these 5 data points might seem familiar to you is if you've watched the previous video of Average Schmaverage Part 2, you'll note that we've used these 5 data points before. We found the average of these 5 data points, and we found the average of these 5 data points. And in fact, the average of this data set was 4, and the average of this data set was 15 because of that 61. So let's see what the worksheet has to say and how it enforces this value. Examine the 2 familiar data sets and look at their middle number, or median. Notice that the median of each set is 4. The fact that the last number of the second data set is an outlier does not change the median. Now, I want to say something before I move the video again, because I feel like I may have glossed over something that was very important with this statement right here. This statement says that the fact that the last number is of the second data set of the outlier does not change the median. This means that the median is resistant to outliers. An outlier does not change the median. So the median has this resistance to getting pulled by extreme values. And that's why it's probably the better choice in a skewed data set. Now, let's go and take a look at these next 3 examples. If the data is written from least to greatest, we can easily find the middle. In the case of an even set of numbers, the median is the average of the 2 middle numbers. So you'll see in the previous example we had 5 numbers, so it was easy to find the middle. But here we have 6 numbers. So the middle of the 6 numbers is actually between 4 and 5. And that would then be 4.5. By adding the 4 and 5 and dividing by 2, you get an answer of 4.5. You'll notice here the order of operations is used correctly by parentheses going first, then division. Here, we're looking at splitting these 6 data points into 3 and 3, so the middle would be the number between 4 and 4, which happens to be 4. The number between 4 and 4 is 4, so 4 plus 4 divided by 2 is 4. Now, in the middle of these 6 numbers, the median is 4 and 17. So what number is between 4 and 17? Well, we would take the 4, add the 17 to it, get a total of 21, and then, 23. I was right the first time, 21. And then 21 divided by 2 gives me my 11.5. Wait a second here. I believe that would be 10.5 if that's 21 divided by 2. So 10.5 would be my median there. So little fixes here. All right, so with that in mind, I am now going to move to our next page and have you run some averages and medians for these sets of data. So with your worksheets in front of you, you've got to do parts A through G, and you can pause the video now, run through those data sets, and get those answers written down, and then finally answer below this question. Explain when it would be better to use an average. Explain when it would be better to use a median. All right, hopefully you have finished, because what I'm about to do is run through the answers here just so you can check your work. We're now going to find out if you got the answer right for the mean and median for each of these answers. If we add up all of these numbers and divide by 6, you'd get a total of 87 divided by 6, which gives you an answer of 14.5. The median is the number between these two, which also happens to be 14.5. So is it a coincidence that the mean and the median were exactly the same? This data set happens to be from 12 through 17 going up by 1, so it's evenly distributed. The mean and the median will be the same since all the numbers are evenly distributed apart from each other. So this is an example of non-skewed data set. Now if we take a look at this data set, we add all these up, we get a total of 119. 119 divided by 6 gives us an answer of 19.83, repeating average, so almost 20. Now if we find the median here, the median is between 24 and 24, and that would be 24, or 24 plus 24 divided by 2, which gives us 24. Now here's an interesting average. You add up all these numbers, you get a big 321, divide that by 6. 321 divided by 6 is 53.5. Now you'll note that 53.5 is actually not even kind of normal in this data set. This is definitely a data set that's skewed to the right because most of our data is on the left here. The median is between 44 and 44, which is 44. So this is an example of a skewed data set that has probably a more accurate median than average. And then finally, not finally, but for this data set, we have a total of 9 data points that add up to 48. And when I divide that by 9, I get 5.3 repeating. My median is going to be in the middle of this 9 data points, so that would be exactly on the 5th number, because this balances off with 4 on the left and 4 on the right and 1 in the middle. My median is 7. So let's take a look at the bottom set of answers here for E, F, and G. So adding up all these numbers here, I get a total of 129, and 129 divided by 9 gives me an average of 14.3 repeating, and the median will also be 7. If you compare this versus the previous answer, let's kind of bring this back up here a little bit, you'll notice that by adding a 0 to the last data point here, it drastically increased this average to 14.3 repeating. But the median stayed exactly the same, with 4 points on the left, 4 points on the right, showing again the median's resistance to outliers. So with this data set, slightly different. We now have 10 data pieces instead of 9, and we have in the numerator now a 57 instead of a 48. This is an example of how by adding one extra data point will actually not change the average that much, and the median stays exactly the same. Medians still have resistance to outliers, but that median is splitting these 5 data pieces on one side and 5 data pieces on the other. Now I hoped when you got to part G, I hope you didn't try to find the median, because putting a line between the 1 and the 9 is neglecting something pretty important. You should have your numbers in order. So I'm putting my numbers in order, 1, 2, 3, 4, 6, then 9, and then this becomes my new spot for my median. My median is between 3 and 4, or 3 plus 4 divided by 2, which is 3.5. And my average is going to be 1 plus 2 plus 3 plus 4 plus 6 plus 9, which is 25 divided by 6. 25 divided by 6 is 4.16 repeating. That 6, then now you can see that we have a pretty symmetrical group of data, but it is skewed a little bit to the right because most of our data points are on the left. The 1, 2, 3, and 4 are weighted more on the low end of the number line, and the 6 and the 9 are on the right-hand side of the number line, so this is definitely skewed to the right. You can tell your skewness if you compare your averages and medians together. So for our final question of the worksheet here on this first part of average, or first part of our capstone project, or the last part of the video of average Schmaverage, when would it be better to use a mean? When would it be better to use the median? So I hope that through the course of these videos you've learned it's probably best to use a mean when you have a more symmetric set of data. It would also be better to use a mean when you have to include all of the data points and you don't and you want to be cognizant of outliers. Well, when would it be better to use a median? The median definitely shines when you're trying to find the best representative number of a skewed data set. That way the outliers that it is resistant to will not affect the number that best represents the data set. Obviously, one downside to using a median, since we talked about the downsides of using an average because of outliers, one of the downsides of using the median is that sometimes the median isn't actually one of the data points. You can have a median that's like between two numbers that actually are no data points in there at all. So for example, if I had, let's say 6 data points, I have a 1, a 2, a 3, a 17, an 18, and a 19, the middle would be 10, or the median would be 10, and there's actually no data point that's actually at 10, because 3 plus 17 is 20, 20 divided by 2 is 10, but since there's no actual data point there between these 6 numbers, the median is not a good representation of this data set because no one was actually there. So sometimes medians are misleading as well. Now, in the next capstone video series, we're going to explore averages, normal curves, and something that's going to actually make the average a lot more reliable, or a lot more readable, a lot more meaningful, is this concept of standard deviations. So thank you for watching all three video parts. If you haven't watched the first two, please go back and watch Average Schmaverage Part 1 and 2. But I thank you for watching, and have a good day.